You are welcome to today's session. My name is Olivia Namgera, and I'm working alongside Buyinza John. I hope you have kept yourself safe and useful at home. Continue to keep yourself safe by washing your hands regularly with clean water and soap. Please get a pen, a book, a calculator, and let's get started with this amazing lesson. Today we are going to talk about motion. Motion is about the movement of objects or things. So, by the end of this lesson, you should be able to define speed. You should be able to understand the relationship between speed, distance, and time. You should also be able to solve mathematical problems involving speed. How will you know that this lesson has been successful to you? You will know when you are able to define what speed is, when you can describe or give the relationship between speed, distance, and time, when you can solve mathematical problems involving speed. Before we begin our lesson, I want us to do a simple demonstration to really see what is involved with speed, distance, and time, and how their relationship works. I want you to get up from where you are. Can you please stand up? If you're seated, just stand up. From the point where you are, move into any direction of your choice. You can decide to move to the left or to the right. Let me take a few steps myself. What do you notice about my movement? Number one, can you think about my movement? What is that one thing that you have noticed about my movement? Yes, I have changed position from one point to another. You are a great observer. Thank you so much for that. I want you to take great notice of this. There is some length between these 2 points. The point where I was standing initially and the point where I am standing finally. Can you guess what is in between those 2 points? It is the length. Thank you so much. Now, that length, we have a definition for that length. Can we tell what that length is called in this case? The length between 2 points. What is it called? Very good. It is called distance. Let us take an assumption that one pace is approximately to 1 meter. I took 2 steps, so that means our approximation there will be, very good, 2 meters. Now, number 2, that was number 1 we noticed. Number 1, we noticed that there was some distance I moved between these 2 points. Number 2, while I was moving, I took some time. While I was moving, time went on. So, we can say that there was some time taken for me to move from this point to a final point. Can we try to time ourselves and see how much time we take from moving from one point to the other point? Let us only take 2 paces. Remember, we said that 1 pace is approximately to 1 meter. Now, your 2 paces will be approximate to 2 meters. Can you please try it? Get a watch. You can get a watch and time yourself as you take those paces. From what we have done, how fast do you think you can move? Can you try to determine it? You might ask yourself, now how will I know how fast I have moved? We are here to learn about that kind of thing. We are here to learn about speed. We want to know the speed that you have used while moving between those 2 points. Now, to determine the speed you have gone through, you have to follow a simple formula. You have to follow a simple formula. Can we try to think about that formula? Do you know what this formula is? Yes. Speed is equal to, can we guess? Speed is equal to distance over time. Have we got that? Can we do it one more time? Speed is equal to distance over time. Now, from our demonstration, do we remember the distance? Yes, the distance was 2 meters. Have you timed yourself? Did you find out how many seconds you took taking those paces? Yes, that is our time. Can we try and put that information into our formula and try to find the speed you have used from one point to the other? You can take a minute and write that down, calculate it. Very good. Have you been able to find how fast you have moved? That is very good. That is our speed. From our demonstration above, we can say that speed is the distance covered in a unit time. Or we can say speed is the rate of change of distance. We can simply represent this in a formula. And our formula says speed is equal to distance over time. It can be measured in kilometers per hour. When we write kilometer per hour, we used a slash forward. Kilometer slash forward hour. Or speed can also be measured in meters per second. Remember, the slash forward represents per. Now, since you have demonstrated that practically you have found your own distance when you move through those 2 points, you did calculate your time, and you've determined your speed, I want you to work out this example, and let's see if you've really got what we mean. Can we try out this question? With your pen, please write down this question in your book. Jane is to walk 600 meters in 5 minutes. Jane is to walk 600 meters in 5 minutes. How fast should Jane walk to cover this distance in the given time? How fast should Jane walk to cover this distance in the given time? What does this question require us to find? Can we read through the question just one more time to see what is required of us? Okay. Jane is to walk 600 meters in 5 minutes. How fast should Jane walk to cover this distance in the given time? Very good. If you've been thinking, you should be able to realize that right now what is required of us is the speed. We need to determine the speed at which Jane moves. Let us use our formula to see if we can solve this question. Are you ready? Can you note down the formula that we learned a few minutes ago into your book? What have you written? Very good. Speed is equal to distance over time. Whenever you're given a question in physics, especially a question that requires you to solve some problems mathematically, make sure you read the question and understand it. And after understanding it, break it down, okay? Summarize the information in that question so that your work is made easier while solving a problem. Can we go on? Let's look through our question. Jane is to walk 600 meters. What does the 600 meters represent? It represents the distance. So we already know the distance, right? Very good. And then we go on, breaking down our question. We have been told that Jane is to walk 600 meters in 5 minutes. So our time that we've been given is 5 minutes. But remember, we have said that speed has units, can be measured in kilometer per hour or meters per second. Let's try to look at this question one more time. Our distance is in meters and our time is in minutes. Is this what we need exactly? Can we just feed our information in the formula? Yes? No? Why not? We are not going to feed the time into the formula because we've been told that our speed is either measured in kilometers per hour, but our distance is not in kilometers, it is in meters. So that means that we have to use the other unit, which is meters per second. But our time is in minutes. So we need to convert our minutes into seconds. Very good. So we are going to convert our 5 minutes into seconds. We know that 1 minute is equal to 60 seconds. Then how about 5 minutes? How do we convert 5 minutes to seconds? We are going to get our 5 times the 60, which 60 represents seconds that we count in 1 minute. So when you get 5 times 60, we get 300 seconds. Very good. So now we know we have the distance, which is in meters, and also after converting our 5 minutes to seconds, we now have our time in seconds. Very good. So what do we do next? We are going to comfortably substitute our details into our formula, and then we get the speed at which Jane moves. Yes. So our speed will be equal to 600 meters over 300 seconds. Can you calculate that very fast and get the final answer? What final answer do you get? Very good. 2 meters per second. Therefore, distance covered in a unit of time is the rate at which Jane moved. And Jane moved at 2 meters per second. That was her speed. So in summary, we are going to say in physics, the term used for distance covered in a unit time is speed. And we know that when you are given the formula speed is equal to distance over time, you can also play around with that same formula to find the distance. In order for you to know how to calculate the distance given the speed or the time, the formula we use is distance is equal to speed times time. What if you're given the distance and the speed, but you're not given the time? What do? What formula do we follow? We say that our time is equal to distance over speed. So, I believe you have enjoyed that activity as much as I have enjoyed it. But the most important thing here is for you to know what speed is and the relationship between distance, speed, and time. I believe we have looked at that in the previous minutes. If you have been paying attention, you'll be able to answer those 2 objectives. We've already ticked them off on our list. Now, we've even gone ahead and solved some mathematical problem involving speed. Don't you think our lesson is about to end? But before it ends, can you get your pen and book and try to solve this problem on your own? Try to do it in your free time. Are we ready? Okay. Can you note this down in your books? Aziz walks to school every morning. Aziz walks to school every morning. If his school is 840 meters away from home, if his school is 840 meters away from home, what is his speed if he walks for 7 minutes? What is his speed if he walks for 7 minutes? Can we try to work that out and find the answer? Do you think you can solve that problem now? Let us now see what happens in cars or motorcycles. For someone to know the speed at which they are moving while using a car or a motorcycle, they have to look at the speedometers on the motorcycles or on the cars. Ask yourself, why is it necessary for the driver or the cyclist to know their speed? Can you try to think about that? Well, if cars and motorcycles have speedometers, how would human beings know how fast or how slow they are moving? This question will be answered by the activity that I'm going to leave with you. Please do it in your free time. The question is, at what speed will you walk around the house? At what speed will you walk around the house? What you will need are the following. You will need a tape measure or a meter rule. You will need a stop clock or a stopwatch. If you don't have any of this, you can use a watch, simply a watch. In case you cannot get a tape measure or a meter rule, please ask an adult at home to count the number of his or her paces around the home. When I talk about paces, I mean the steps they take in one stride. Please ask them to count their paces around the house so that you will know the distance around the house. Let us use an approximation or an assumption that one pace of that adult is equal to 1 meter. Let that adult move around, count their paces, and then you can convert them to meters. This is the procedure you have to follow. Procedure number 1, measure the distance around the house. You can either use a tape measure or a meter rule, or you call that adult at your home. It could be your mother, your father, maybe your sister, brother, or even your guardian. Call them. Let them move around the house using their paces. Remember, we have said that one pace is approximately equal to 1 meter. That is procedure number 1. Procedure number 2, walk around the house using the clock to note the time it will take you to go around the house. If you're not using a tape measure or a meter rule and it is your parent or guardian who is moving around the house using paces, you can move along with them while you note down the time they are using. That is procedure number 2. Procedure number 3, determine your speed. How will you determine your speed? Let me give you a hint. You're going to use our formula we've learned today that says speed is equal to distance over time. But remember, you've already calculated the distance around the house, yes, and you've already determined the time that it has taken you to count that distance around the house. So get that information, feed it into the formula, and determine your speed. Now, after you've done this activity, remember you've been walking around the house. Next, I want you to walk faster around the house and find the distance that you get when you walk faster around the house and the time. And then determine the speed. That will be your speed number 2. And then after you've walked around faster, try running around the house. Determine the time you take while running around the house. You then get that new time and feed it into your formula. Determine that distance. After you've gotten these 3 categories of answers, try to compare them. Are they the same? What do you conclude from your experiment or demonstration? I thank you so much for staying and learning with me. Today's lesson has been extracted from Senior 3 work. I request you to please continue staying safe wash your hands, and practice social distance. Thank you so much. I wish you a nice day.